we're going to take a look at the applications of radian measure in terms of a circle. We are going to look at a length of an arc of a circle. So that's going to be, I've got a circle drawn here. It's going to be just a portion of this circle that's intercepted by these two radii. So we're going to learn to find the length of the pink arc, and I'll even explain to you as to why. We're also going to find the area of a sector, and I'm going to go ahead and scroll down so that I can draw that on a picture down here. So the area of a sector is going to be about finding the area of a piece of pie, actually. So just this, what's the area of a sector? So we're going to do that next. And then finally, the best application of all of this involves angular velocity. That's going to be a great bit of fun, and we're going to do a project involving that. You know, it really has to do with RPMs of something that's turning. So for example, the wheels, the tires on your car are turning at so many RPMs, and then they report back to the computer what the speed is that you're traveling based on the radius of your tires and the RPMs with which they are rotating. So it's a real fun piece for us to do. I'd like to go ahead and do possibly the first and second objectives in this segment of video. So what is an arc? Well, first of all, the distance around, I'm sorry about the mouse moving. The distance around a full circle is the circumference of the circle, and the formula for that is 2 pi times the radius. And we've done this before. That's because you can take 6.28 of the radii around the circumference. I'm going to turn to red here. So you can take 1, 2, 3, 4, 5, 6.28 radii around the circumference of a circle. So if you take the number of radii times the radius, then you get the distance around. Well, if we want to find the distance around a portion of a circle, we're going to use theta in radians, because 1 radian is about 57 degrees, and that's because that's the length of 1 radius on the circumference of the circle. So it's going to be pretty much, you know, the circumference is, or the distance around a sector or a portion of an arc is going to be the angle theta in radians times the radius. The next one's a little bit harder. The area of a sector is developed from the formula A equals pi r squared. And what I've done here is I've typed a statement that's true. Half of 2 pi is 1 pi. So you see the pi in this equation, pi r squared. Here pi as well. I'm going to replace pi with half of 2 pi. 2 pi being the distance around the full circle. But what we're going to do is we're going to find the area of a portion of the circle, not the whole circle. So theta is going to be substituted in radians as we go ahead to find area calculations. So these two equations, theta must be in radians for both of them, but their use or their applying is quite simple, really. So here we go. Number one, for an arc length S, an area of a sector A, and a central angle theta with a radius r, find the indicated quantity. So in this problem, I want to find S. I'm going to change to a black marker. So S is found by taking theta times the radius. And in this case, theta is given to us without a degree symbol. It's 2.65. I therefore know that that's in radians. Now I'm going to multiply by the radius, which is 21.2 centimeters, and I'm going to be done. The value for that one is 56.2 centimeters. So again, what you've done is you've found the length of an arc on a circle whose radius is 21.2. So this is 21.2, but you're passing through an angle of 2.65. Struggling to get the colors I want. So 1 radii, 2 radii, here's 3, so about right there. So you got the length of this arc when this was 21.2. Here's 21.2, here's another 21.2, and here's a little portion of it, 65% of it. And so a total of 56. In question number 2 here, you've just got to convert theta from degrees to radians. So get my black pen. So let's go here and let's take the 73.61 degrees and let's multiply that by pi over 180. I'm afraid I don't have that value. It's probably 1 point something. Maybe I'll go ahead and crunch that really quick. I don't have a calculator, so I'm going to have to not do that. That's going to be my theta in the formula S equals theta times the radius, 0.3456 feet. So when you take this value of 1 point something-ish, and you multiply it by 0.345, you get 0.4440 feet. That's the length of the arc at a 73-degree angle is the central angle. The area formula is 1/2 theta times the radius squared. So let's go ahead now. This one, theta is ready to go. So theta is given to us in radians. There is no degree symbol. So to find the area, I'm going to take half of 3.97 times the radius of 15.7 inches. I'm going to square that number, and when I do that, you should get 489.3 inches squared. Number 4 is ready to go as well. Number 4, the angle theta is in radians too. So this has not got a degree symbol. Matter of fact, it's in terms of pi. So I'm ready to go ahead and take 1/2 theta times the radius of 46.3 inches, square that, and when I do, I get 1,347 square inches. Again, please remember that what you have found here, and I'm going to show you some examples of landscaping, of windshield wiper blades, etc. But what you found is for a circle whose radius is 46.3 inches in length, 2 pi over 5 is about a piece of pie about like right there, and you found the area just now of that, 1,347 square inches. The next problem, the 123 degrees has to be converted into radians. So the 123 has to be multiplied by pi over 180. Remember, the reason for that is these are in degrees, and so the degree symbols will cancel out. I can tell you that that's about 2. So when you take half of theta, which is approximately 2, I'm just going to put here, times the radius of 0.214 miles squared, I got an answer of 0.049 square miles. I'm going to write it here as miles to the second power. Again, what I would have typed here though is I would have typed 1/2 times in parentheses 123 times pi over 180. I'd close my parentheses, I'd open, and I'd go 0.214, close them, and I'd raise that to the second power and hit enter and get this answer. it's going to get a little bit harder. So I'm going to pause, let you think about this a little bit, and we'll start our next segment at that point.